Hello, everyone. My name is Jin Cui. I'm a health data science fellow at Insights, and it's my pleasure to introduce you to my Insight project, FireCaster, using neural network to forecast wildfire damage in Australia. Flinders Chase National Park on Kangaroo Island, Australia, is a home to many endangered species, and it's also an ecotourism hotspot, attracting hundreds of thousands of visitors every year. But much of it has been destroyed by the ongoing wildfire, which has killed more than half of its native wildlife population. One of the big challenges facing the animal rescue team is that the wildfires usually spread very fast, and there's little time for animal rescue team to make preparations and to plan evacuations. So the goal of my project is to build an early warning system to forecast wildfire damage 5 days ahead of time so that the animal rescue team can take preemptive measures to save animals. So this is my data analysis pipeline. I get my data from Google Cloud Platform. So first of all, I have the satellite imagery data from Sentinel, which I wrote a SQL to query the URLs, download the images, process them into GeoTIFF, resized and cropped into 1000 by 1000 pixel region as shown in the white box. I also have the daily weather data from NOAA, which is converted into NumPy array before I give both of these data into my deep learning model trained on Keras and TensorFlow. So I use delta normalized burn ratio, or DNBR, to label burn severity. NBR is a geospatial index which uses two infrared wavelengths to measure burn severity. The first glance of the data shows that there's an imbalance problem because there's only two major wildfire outbreaks in the past 2 years. So the solution to that is to subdivide the 1000 by 1000 region into 25 200 by 200 zones. So the ultimate goal of my model is to predict for each zone, the risk probability, the wildfire burning's risk probability in the next 5 days. So the figures on the left shows that most of the zones are not under serious risk. So the advice to give to the animal rescue team is to sit tight and get prepared. Whereas the picture on the right shows that most of the zones are under serious risk. So the advice to give to the animal rescue team would be to go out and save the animals. So a little bit of feature engineering. So while exploring features which are important for wildfire predictions, it's intuitive to think that the burn status of any given time point is dependent on the status from its previous time points, which is the case as shown in the Pearson correlation plot. Besides the temporal correlations, there's also a spatial correlation, which basically means that the burn status of a zone is dependent on the burn status from its neighboring zones, which is why I generated the adjacency features, which are basically the proportion of burn areas from its neighboring zones. So besides that, there's also a weather components, but it plays less important role here. So my model has to incorporate all of these features. And because this is a time series model, this is a time series problem, I use a time series model, LSTM. And to deal with the image inputs, I use a simple convolutional neural network, VGG16. And to deal with the adjacency feature as well as weather features, I use multi-layer perceptrons. Their outputs were first concatenated before being fed to the LSTM layers, which ultimately will give us the zone risk probability in the next 5 days. And this is my model performance. It performed fairly well on both the validation as well as the test set. I'm mainly looking at F4 beta score because in my perspective, it's more important for the model to be able to tell if there will be a wildfire outbreak in the next 5 days. as opposed to giving false alarms. So the recall is really more important as opposed to precision. So this is my app. It's built on Dash and it has multiple pages. And here you can select the dates and see the burn status as well as the model predictions. And here is some EDAs looking into past wildfire as well as weather records. You can select the dates, filter by the wildfire intensity, select stations, and it will give you the interactive maps. So a little bit about myself. My background's in plant biology. I received my PhD from Penn State, where I was working on maize genetics, looking into a mysterious corn mutation which produces a type of secondary metabolites, which can potentially be used as a fungicide. I'm exposed to big data and bioinformatics, and here this is a plotly tool that I wrote to help people generate circus plots. Besides that, I also participated in several Kaggle competitions, working on machine learning and deep learning problems before I joined Insight as a Help Data Science Fellow. And with that, thank you all for your time.